Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique hexagonal pyramid having edge of the base equal to 30 millimeter and axis height has been provided to us as 55 millimeter. Now this hexagonal pyramid is resting on one of its edges of its base onto the ground while the axis is inclined at an angle of 30 degree to the horizontal plane. Let us first of all evaluate the orientation of this hexagonal pyramid with respect to the horizontal plane. So if we locate the base of this hexagonal pyramid into this orientation and then we tilt this hexagonal pyramid either this way or this way. So it will be resting on one of its corners onto the horizontal plane or onto the ground. So this way the requirement that this hexagonal pyramid is resting on one of its base edges onto the ground. So this will not be fulfilled over there. So this is the incorrect orientation of this hexagonal pyramid over here. So now if we are going to locate the hexagonal pyramid into this orientation, then either we tilt it this way or we tilt this hexagonal pyramid in this way. So it will be resting on one of its base edges onto the ground while the axis of this hexagonal pyramid happens to be inclined with respect to the horizontal plane at an angle of 30 degree. So we have to rotate this hexagonal pyramid through the apex point either this way or this way. So it will be resting onto the ground on one of its base edges over there. And now since it will be resting on one of its base edges onto the horizontal plane, so the projections of this base edge onto the horizontal plane will be appearing as true length into the top view projections over here. So now we are provided with the information that in the second iteration, this edge onto which the pyramid is resting onto the ground, so this edge true length, it is further inclined at an angle of 45 degree with respect to the vertical plane. So this edge further we are required to rotate at an angle of 45 degree with respect to VP. So this becomes an oblique hexagonal pyramid which happens to be inclined with respect to the horizontal plane as well as with respect to the vertical plane. So we are required to obtain the orthographic projections of this oblique hexagonal pyramid. So let us first of all proceed with the construction of the orthographic top view and front view projections of the hexagonal pyramid which is standing upright and it is resting with its base onto the horizontal plane. So if we look at this right hexagonal pyramid from the top, so we are going to obtain the hexagonal projections onto the horizontal plane to begin with, wherein these two edges, that is AB and DE, so they will be perpendicular to the vertical plane. So we know that the edge length of this hexagonal pyramid happens to be 30 millimeter. So we have drawn 30 millimeter hexagonal construction onto the horizontal plane below the XY reference line. Now we have to locate the apex point. So we need to join the diagonals AD, BE and CF over there. So wherever these three diagonals they intersect with each other, we obtain the axis points O and O1 corresponding to this hexagonal pyramid. So we can see once we obtain the axis points, now all the six slant edges OA, OB, OC, OD, OE and OF. So all of these slant edges, they will be visible to the observer as the observer is looking at this hexagonal pyramid from the top. So this way we have completed the top view projections of this hexagonal pyramid which is resting onto its base on the horizontal plane. Now let us obtain the front view projections of this hexagonal pyramid. So in order to obtain the front view orthographic projections of this hexagonal pyramid resting onto the ground, now we know that this is the axis point O and O1. So through O and O1 we have drawn the axis over there. Now we also know that the height of the axis of this hexagonal pyramid happens to be 55 millimeter. So we have marked the axis height of this pyramid as 55 millimeter. The moment we mark this axis height, so we can locate a point corresponding to the apex, that is point O, onto the axis line over here. So now we can join this apex point with A dash and B dash, as well as with D dash and E dash over here. So now once we join this apex point with B dash, A dash, so we get this projection line over here. Similarly, once we join O dash with C dash, F dash, so we obtain this projection line over here. And similarly, once we join this apex point with D dash and E dash, so we get this projection line over here. But one thing we need to understand, that these three slant edges OA, OF and OE, they are lying on the rear side of this particular solid. So the front view projections corresponding to OA, that is O dash A dash, front view projection corresponding to OF, that is O dash F dash. Similarly, the front view projection corresponding to OE, that is O dash E dash, should have been drawn as dotted line or hidden line projections over here. But these projections, that is OA projection in the front view, so O dash A dash hidden line projection has been superseded or overlapped by the projection of the slant edge OB in the front view projection. So O dash B dash, it has superseded or it has overlapped with the hidden line projection of the edge OA, that is O dash A dash. So that is why we are not able to observe O dash A dash as a hidden line projection in the front view. Similarly, the hidden line projections corresponding to the slant edge O dash F dash, they have been covered by the object line projections corresponding to the edge O dash C dash. We can see OC edge, it has superseded the edge OF over here. Similarly, here we have the dotted line projections corresponding to OE, that is O dash E dash, they have been covered or superseded by the object line projections corresponding to the slant edge OD. So therefore, O dash D dash projections, so they have superseded the dotted line projections corresponding to the slant edge O dash E dash over here. So this way we have been able to obtain the front view projections, the top view projections of the hexagonal pyramid which is resting on its base onto the horizontal plane. Now we have been provided with the information that in the first iteration, this hexagonal pyramid has been tilted in such a way that the axis of this pyramid happens to be inclined with respect to horizontal plane at an angle of 30 degree, or the base of this pyramid will be inclined at an angle of 60 degree with respect to the horizontal plane, and this hexagonal pyramid will be resting on one of its base edges onto the ground or onto the horizontal plane. So what we have to do, these front view elevation projections which we have obtained for the right hexagonal pyramid resting onto its base onto the ground. So these projections, now we have to rotate or transform in such a way that point D dash E dash should be resting over here onto the ground. Now the base of this hexagonal pyramid should be inclined at an angle of 60 degree with respect to the horizontal plane, such that the axis will be inclined at an angle of 30 degree with respect to the horizontal plane. So to begin with, we have marked the inclination of the base as 60 degree. Now you can check 3 points I can mark over here. D dash, E dash will be lying over here. C dash, F dash and O1 dash, this distance I can mark over here. And then the distance between D dash, E dash and B dash, A dash I can mark over here. And then from this point C dash, F dash, using rectilinear distance, I know the axis height is equal to 55 millimeter. So from this point axis height I can mark as 55 millimeter over here. So now you can check this distance marked over here. This should be equal to D dash, E dash and C dash, F dash over here. This distance, it will be marked as distance between C dash, F dash and B dash, F dash over here. And finally this distance we have marked as axis height is equal to 55 millimeter. Now since we have not been provided with the inclination of the base with respect to the horizontal plane, so this portion now we are going to eliminate, because now we have drawn the axis which is marked at an angle of 30 degree. That is why we have marked this with black color. So now we can just remove the inclination of the base over here. It is only to facilitate ease of construction that we were showing that the base of this particular hexagonal pyramid has been inclined with respect to HP at an angle of 60 degree. Now we take this out. Now we can see that here we have a hexagonal pyramid resting on one of its base edges D1 dash, E1 dash onto the ground, when the axis of this hexagonal pyramid happens to be inclined with respect to the horizontal plane at an angle of 30 degree. Now we can also join this dark, that is O1 dash, C1 dash, F1 dash. Again it will be joined using object line, because it was appearing as an object line in the previous elevation projection view. So now we have been able to obtain the elevation projections corresponding to the inclined hexagonal pyramid when the inclined hexagonal pyramid happens to be resting onto the ground on one of the edges of the base, while the axis is inclined with respect to horizontal plane at an angle of 30 degree. Now we are required to obtain the top view projections corresponding to this inclined hexagonal pyramid. So how these top view projections they can be obtained? When we are going to look at this hexagonal pyramid from the top. So how many points they are available with us? 6 points corresponding to the base are available. 2 points corresponding to the axis they are available. So total of 8 points they are available with us in the elevation projection view. So now through these 8 points we are going to draw the vertical projectors into the plan projection view. Now wherever these vertical projector lines drawn through the 8 points of the elevation projection view, they are going to intersect with the horizontal projector lines drawn through the corresponding points of the plan projection view which we had already obtained in the previous iteration. So these points of intersections will provide us with the location of the corresponding points in the plan projection view. So let us obtain these corresponding plan projection points corresponding to this inclined hexagonal pyramid. So the first point available with us, it is F. Now once we draw the horizontal projector line through the point F of the previous plan projection view, now wherever this intersects with the vertical projector line drawn through the point F1 dash, we obtain the point F1 over here. Now next we have the points A and D over here. So this is point A, this is point E. Now let us draw the horizontal projector line through the points A and D. So wherever this horizontal projector line, it will be intersected by vertical projector lines drawn through A1 dash and E1 dash over here. So please check, the vertical projector through A1 dash is going to intersect with this line over here. So we obtain the point A1. Similarly, the vertical projector line drawn through the point E1 dash will intersect with this horizontal line drawn through the point E over here. So this point of intersection provides us with the location of the point E1. Next, we have got the points O and O1. So through O and O1, again we have drawn a horizontal projector line. So wherever this horizontal projector line will be intersected with vertical projector lines drawn through O1 dash and O11 dash. So we are going to obtain the points O1 and O11 in the top view projections over here. Next, we have got the 2 points B and D. So through points B and D, again we have drawn a horizontal projector line. So wherever this horizontal projector line drawn through the points B and D will be intersected by the vertical projector lines drawn through B1 dash and D1 dash. So this is B1 dash, this point, and D1 dash is this point. So this is the vertical projector line emerging from B1 dash. So wherever it intersects with the horizontal projector line drawn through B, we obtain this intersection point as B1. Similarly, this is vertical projector line drawn through D1 dash. This is horizontal projector line drawn through point D. So this intersection of these two projection lines provides us with the location of the point D1 over here. And finally, here we have the point C. So through point C, we have drawn a horizontal projector line. Through point C1 dash, we have drawn vertical projector line. So this intersection of these two projector lines will provide us with the location of C1 in the plan projection view. So this way, all the 8 points of the plan projection view corresponding to this inclined hexagonal pyramid, they have been obtained. Now we are required to join all the edges over here. What are the edges which we want to join in the plan projection view? A1 B1, B1 C1, C1 D1, D1 E1, E1 F1 and F1 A1. And also we need to join the slant edges O1 A1, O1 B1, O1 C1, O1 D1, O1 E1 and O1 F1. But which one of these edges we have to join dark? Which one of these edges we are required to join using hidden line? That is, so let us look at the solid from the top. So as the observer is going to look at the solid from the top, so the points which are farthest away from the observer, they are D1 dash and D1 dash. It means that these 2 points, they are not visible to the observer. So in the top view, anything joining D1 and D1 should be drawn using dotted line unless those edges, they will be falling into the boundary of the object. So let us start joining these edges in the top view. So we can see E1 F1, it is not falling in the boundary, so it has been drawn dotted. E1 D1, it is not falling in the boundary, it has been drawn dotted. And C1 D1, it is not also falling in the boundary, it has been drawn dotted. So now other edges, they have been drawn dark. But again, E1 O1, it is again not falling in the boundary. So O1 E1 slant edge has also been drawn dotted, and O1 D1 slant edge has also been drawn dotted over here. So this way we have been able to complete the top view projections corresponding to the inclined hexagonal pyramid when the pyramid is resting on ground on one of its base edges D1 dash, E1 dash, and the axis of this pyramid is inclined at an angle of 30 degree with respect to the horizontal plane. Now we have been provided with the information that in the second iteration, the edge onto which this hexagonal pyramid is resting onto the ground, which is this edge, DE. So in the top view, we have obtained the true length projections of this particular edge onto the horizontal plane. How we have obtained the true length of this particular edge? Because this edge D1 dash, E1 dash, it happens to be contained by the horizontal plane. So since this edge D1 dash, E1 dash is contained by the horizontal plane, so the top view projections D1, E1 will be representing the true length of this particular edge. Now since we have got this true length available over here, Now, the inclination of this true length with respect to VP will be marked by this angle phi over here. Now, E1, D1 will be resting onto this orientation line which is inclined at an angle of phi is equal to 45 degree with respect to the vertical plane. So now what we will be doing, whatever plan projection view we have obtained over here corresponding to this inclined hexagonal pyramid, now these projections we have to transform or rotate in the into this view over here in such a way that D1 E1 edge, it should be resting alongside this projection line which we have marked over here. Now how this transformation or rotation we are going to carry out? So this rotation or transformation will be carried out using a simple fundamental of transformation of rectilinear distances over here. So now we can see this hexagonal base, it is contained by or it is inscribed by a rectangular construction over here. So this rectangular construction we are going to draw over here, and all the 7 points corresponding to the base including the axis, so they will be appropriately marked within this rectangular construction which will be corresponding to this rectangular surface which is inscribing this hexagonal base over there. So thereafter we are going to mark the apex point over here using the rectilinear distances transfer. So this way, this plan projection view which we had obtained earlier will be transferred or rotated at an angle of 45 degree with respect to the vertical plane. Now we can check. Here we have got this rectangular box which is inscribing this hexagonal base of the solid. Now different points we are required to mark. So we can see this is the longer edge. So this longer edge we have drawn. This is shorter edge of the rectangular construction. So this has been marked over here. Now we can check alongside this shorter length, one intermediate point is available over here, C1 as well as F1 over here. So this construction line if we draw, so we will be able to locate the points C1 and F1 over here. Similarly, alongside this longer edge, 1, 2 and 3 construction lines they will be required. So we can see this is construction line corresponding to the axis and the apex. This is construction line corresponding to the points C1 and F1. Now 2 more construction lines we require in order to locate A1, B1 and E1, D1 over here. So let us do that. If we locate these 2 points, so we can locate A1, B1 over here and E1, D1 over here. So as we have discussed that this is the edge onto which the hexagonal pyramid happens to be resting onto the ground. So this edge E1, D1 must be lying over here. So let us mark all the 8 points from the previous construction using the principle of rectilinear distance transfer over here. So this way we have been able to mark all these points. This point is A2, B2, C2, D2, E2 and F2. This point happens to be O21 and this point happens to be O2 over here. So all the distances they have been measured in the rectilinear way and they have been transferred from the original plan projection view to the new plan projection view. Now only the orientation has been changed over here. So once we have marked all these points, now we can join all these edges in the same way as they were joined in the earlier plan projection view. So now we have been able to obtain the plan projection view for the oblique hexagonal pyramid, which happens to be inclined with respect to the horizontal plane and which happens to be inclined with respect to the vertical plane as well. So now we have been able to obtain the plan projection view for this oblique hexagonal pyramid. Now we will be obtaining the elevation projection view corresponding to this oblique hexagonal pyramid. Now how that can be done? As we are looking at this particular pyramid from this orientation, now how many points do we have in the top view projection view over here? That is 8 points they are available with us. So from all of these 8 points, what we are going to do? We are going to draw the vertical projector lines and extend them into the elevation projection view. And now what we will be doing in the elevation projection view, from all the 8 points of the previous elevation projection view which we had drawn, we are going to draw the horizontal projector lines, and wherever we are going to find out the intersection points of the corresponding points, we are going to obtain the elevation projection points over here in the elevation projection view. Let us now evaluate the location of these 8 elevation projection points corresponding to this oblique hexagonal pyramid. So first point we have available with us, this is O1 dash. So from O1 dash, we have drawn a horizontal projector line. So wherever this horizontal projector line will be intersected by vertical projector line drawn through the point O1, so this intersection point will be providing us with the location of the point O2 dash in the elevation projection view. Now the next 2 points available with us, they are B1 dash and A1 dash. So through B1 dash and A1 dash, we have drawn a horizontal projector line. Now, wherever this horizontal projector line, it will be intersected by the vertical projectors drawn through the points A2 and B2, we will be obtaining A2 dash and B2 dash points in the elevation projection view. Now next we have got 3 points, C1 dash, F1 dash and O11 dash. Now we are going to draw a horizontal projector line emerging from C1 dash, F1 dash and O11 dash. So wherever this horizontal line will be intersected by the vertical projectors drawn through C2, F2 and O21. So we will be obtaining the point C2 dash, F2 dash and O21 dash over here. So we can check, this is point C2. If we draw a vertical projector through C2, it is going to intersect with this horizontal projection line emerging from C1 dash over here. So this point is C2 dash. Similarly, here we have point F2. If we draw a vertical projector line through F2, wherever this vertical projector line emerging through F2 intersects with horizontal projector line emerging from F1 dash, we obtain the elevation projection point F2 dash over here. And finally, onto this line, there is third point. Now here, this will be obtained when we draw vertical projector through the axis point O21. So from O21, the vertical projector, whenever it intersects with the horizontal projector line drawn through O11 dash, we have obtained the point O21 dash over here. And finally, these 2 points, they are there onto the base D1 dash and D1 dash. So if we draw a horizontal projection line through D1 dash and D1 dash, they are going to coincide with XY reference line. So whenever this horizontal projector line emerging through D1 dash and D1 dash will be intersected by vertical projectors drawn through the points D2 and E2. This is D2, this is E2. So this vertical projector through D2, whenever it intersects with XY reference line, we obtain the point D2 dash. Similarly, this is point E2. Once we draw vertical projector line emerging from E2, wherever it intersects with the XY reference line or the construction line or the projection line emerging through E1 dash, we obtain the point E2 dash over here. So now all the 8 points of the elevation projection view, they have been appropriately located in the front view projections over here. Now, which edges we are required to join? A2 dash, B2 dash, C2 dash, D2 dash, E2 dash and F2 dash. Also we are required to join O2 dash, A2 dash, O2 dash, B2 dash, O2 dash, C2 dash, O2 dash, D2 dash, O2 dash, F2 dash and O2 dash, E2 dash. Now let us evaluate which one of these edges they should be drawn dotted or as a hidden line and which one of these edges should be drawn as a dark or the object line. So whenever the observer is going to look at the solid from this side, now we find that A2 and F2, these are two edges which are farthest away from the observer. So any of the edges which should be joining A2 dash and F2 dash in the elevation projection view, they should be joined as dotted lines or the hidden lines, unless those edges they are falling into the boundary of the object. So let us start joining all of these edges. Now as we join the edges of the base, we can see A2 dash, B2 dash has been joined using dotted line or the hidden line. A2 dash, F2 dash has been joined with the dotted line or a hidden line. Similarly, F2 dash and E2 dash base edge has also been joined using dotted line. Why? Because these edges, they are not falling into the boundary of the object. Similarly, the slant edges O2 dash and A2 dash should be joined as a dotted line, and slant edge O2 dash F2 dash will also be joined by using hidden line or a dotted line. So this way we have been able to obtain the front view projections of this oblique pyramid, and we have also joined the axis. So axis is O2 dash and O21 dash over here. So the axis has also been represented into the front view projections over here. So this way we have been able to obtain the orthographic front view projections as well as the top view projections of an oblique hexagonal pyramid which is resting onto one of its base edges onto the ground with its axis inclined at 30 degree with respect to the horizontal plane, and the edge onto which it is resting onto the ground or the horizontal plane, this edge is further inclined at an angle of 45 degree with respect to the vertical plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how we can obtain the front view as well as the top view orthographic projections of an oblique hexagonal pyramid when the pyramid happens to be inclined with respect to horizontal plane as well as the vertical plane. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the oblique solids in the coming lectures. So thank you very much. Thanks a lot.